All right, people, jumping in, getting deeper into calculus. All right, toolkit number 27, rules for differentiation. So we did this in our last one. So toolkit number 26, we had a cubic, and then when we did, so this was f of x. When we found the derivative of it, right, we found that it was a quadratic, right, an x squared. I want to say x squared and quadratic at the same time. I couldn't combine them in my brain. And then we found f double prime. So we found the derivative of this one and it became a line. So we went from x cubed to x squared to x. Kind of cool, kind of cool. We'll see how that works here, actually. Um, so we have different notations for finding the derivative. So far, we've used this one, right? We call this one f prime of x. Okay. And we can have f prime of y, we can have f prime of a, we can have different things in there, right? But that's the most common. Um, we can have y prime, right? We know that y is a replacement for f of x. So if I said y equals this, this could be y prime. This could be y double prime. Okay. We can also do this dy. It looks like divided by, and it kind of is, but kind of isn't. Okay. This is dy over dx. And the way we call this is the, I need some space here, the derivative of y with respect to x. So dy over dx. Some people say dy dx. Okay, so sometimes you'll see that. Technically, you would say the derivative of y with respect to x. But a lot of times we just say dy dx. But this means the same as this. Same as this. Um, in the future, you'll see something with a d meaning like a difference or a delta or a change, right? Think about what that would mean here. Change in y over a change in x. It's a slope, right? And what is the derivative? It's a slope, right? So that's one way to think about this as well. All right. This one we could say ddx. ddx is one way to say this, ddx of f of x. We can also say the derivative of f of x with respect to x. Okay? We can have ddy, right? We can do all sorts of fun things. This one, I don't even see it used very often. They include it in the book. This is the derivative with respect to x of f of x. Okay? So the derivative of f of x with respect to x, it means the same thing as this. Okay, but it's got a big capital D. So lots of different notations for exactly the same thing. So this is um, f prime of x. This is y prime. This is dy dx. This is d dx of f of x, right? So you could use all of these to mean this, okay? So it does get confusing when you first start and you don't know that these all kind of mean the same thing, okay? So just throw those out there. The ones we're going to use the most probably are this and this. Um, these two are pretty common as well as you get further into calculus, and pretty useful too. So anyways, let's go. Let's go. Enough notations. Derivative of a constant. Okay, so if I have f of x equals k and k is a constant, it's just a number with no variable on it, then the derivative, the first derivative, is going to be 0. So if f of x is equal to 7, then f prime of x is going to be 0. There we go. That's it. If f of x equals negative 23 pi over 276 pi squared, that is a constant. It's ugly. That pi is not a variable, right? Then the f prime of x would be 0. So derivative of any constant is equal to 0. Always. Cool? Cool. All right. So think about what that means, right? If I had y equals 2, that would be a line at y equals 2. Remember, derivative means slope. Or let's say it's 7. F of x equals 7. So let's say this is 7 right here. This is y equals 7. What's the slope of this line? Rise 0, run whatever, right? It's 0. The slope of a constant is 0. Okay, so thinking about it visually helps as well. All right, derivative of a power. Okay, so f of x equals x to the n for any real number n. Okay, then f prime of x is, I thought that n could not be equal to -1. No, it can. It's okay. I'm thinking of something else. My brain. Then f prime of x is, we take that n, we bounce it out front as a multiplier, and we take our exponent and we subtract 1 from it. Okay? So we bounce the n down first. That goes out front. And then we take 1 away from this. So let's do a couple. X to the 6th. So 6 bounces out front as a multiplier. X to the 6, and we subtract 1. So 6x to the 5th. Ooh, nice. All right, here, what are we going to do? We're going to bounce that -2 out. So the first derivative will be -2x. And then we're going to go -2 minus 1. We're going to subtract 1 from whatever it is. So -2x to the -3. A lot of people can do this. They don't have to do this step. They can go right to it, right? And that's fine. All right, how about x to the 1/2? Well, we're going to bounce this out to the front when we take the derivative of it. And we're going to go x to the 1/2 minus 1, which is 2/2. So 1/2 minus 2/2 is going to be to the -1/2. X to the -1/2. Okay. We'll talk about what that means later. We'll fix that. But for now, I think we're fine. Okay. Yeah, we're fine. All right, here we go. Derivative of a constant times a function. Okay. So if I have k times g of x, right? Then the first derivative is just k times g prime of x. Okay, that multiplier stays out there, and I find the derivative of this. So if I have the derivative of, if I have f of x equals 2x to the 6th, this 6 is going to bounce out. So I keep the 2 out there, right? I'm going to multiply it by, and I'm going to find the derivative of just this. So 2 times 6x to the 5th, right? 6 minus 1 is 5. So that's going to be 12x to the 5th. Cool. For this one, I'm going to bounce this out. I'm going to multiply by what's here. -6 times 1/3 is -2. I'm going to write that out. -6 times 1/3. And then x to the 1/3 minus 1. So -6 times 1/3 is -2. And then x to the, it'll be -2/3, right? And there's that. Cool. There we go. All right. Derivative of a sum or difference. So if I have, if f of x is u of x plus or minus v of x, then f prime of x is just the derivative of the first plus or minus the derivative of the second. Okay, this just means if I have this situation, I can find the derivative of this minus the derivative of this, and I'm done. So let's do it. 6 times 2 is 12, x to the 5th, minus 2 times 3 is 6, x to the 2 minus 1, which is the first. I can leave it like that. You could put a 1 there if you really want to. All right, let's try it for this one. That bumps down, so we get -8x to the -2 minus 1, which is -3. And then it's a plus in between. And then 1/2 times 8 is 4. And then x to the 1/2 minus 1, which is -1/2. Beautiful, right? Beautiful. All right, so let's put it all together. These are beautiful, right? So, oh, this is supposed to be squared. So go ahead and fix that. If you want to try it and pause and try this on your own, go for it. I think you can do it. All right, so let's go. 4 times 2 is 8. X to the 4 minus 1, which is 3. Minus 2 times 3 is 6. Make sure you fix that 2 up there. I forgot to add it in. X to the 2 minus 1, which is just the first. And then we have a constant. So that's nothing, right? You could also think of a constant as like x to the 0 in this situation. 0 times 3 is 0. So that just turns into 0. It's another way to think of that. All right, that's it. Donezo. All right, last one. Last one. Here we go. 1/2 times -4 is -2. X to the 1/2 minus 1, so -1/2. And then this will be multiply out front. So it's plus, but it's going to be -3 out front, minus 3. x to the minus 3 minus 1. So that's negative 4. And then this is minus pi, and that's a constant. So that's gonzo. It's 0. So that's it. We did it. Cool. Is that fun? Oh gosh, I hope you could see that. All right, so we multiplied this times this to get negative 2x, and then 1/2 minus 1 was this. I'll just repeat it just in case you couldn't see. And then we multiplied the negative 3 out front, so that's negative 3x, and then negative 3 minus 1 is negative 4, and this is a constant, so it goes bye-bye, because that's the rules. Sorry, sweetheart. You're out of luck. Can you call math equations sweetheart? I think so. You can call your sweetheart sweetheart. Don't call anybody else sweetheart. Just, just don't. Okay. Math equations and your actual sweetheart. That's it. Just mystery buff advice for you in life. All right. See you, people.